Welcome back to Mr. Vaughn's classroom, where math is made easy. Before we get started on this video, I'd like to ask you to please hit the subscribe button, give this video a thumbs up, and engage with a comment below. Let's get started. This video is looking at Unit 1 on constructions and rigid transformations. This is Lesson 10, which is the first lesson after the mid-unit test. We are now going to begin looking at the rigid transformations portion of the unit. The learning goal in this lesson is to draw some transformations. We have 3 learning targets. When we get done with the practice problems, we'll come back, review these, and ensure you've learned everything you need to in order to be ready before moving forward. Learning target number 1 says, given a figure and the description of a transformation, I can draw the figure's image after the transformation. So whether they tell you that we're going to translate it, whether they tell you we're going to rotate it, whether they tell you we're going to reflect it, you are able to take what they tell you and draw the new image after those transformations. Learning target number 2 says I can describe the sequence of transformations necessary to take a figure onto another figure. So basically they give you 2 figures and they ask you what needed to happen to switch from the first one to the second one, and you are able to describe, was it translated, was it rotated, was there a reflection? What combination had to happen to go from what they gave us in the first figure to what they give us in the second figure? And learning target number 3 says, I know that rigid transformations result in congruent figures, meaning whether we translate, whether we rotate, or whether we reflect, we're still not making it any bigger or smaller, so the sides stay the same size, and we're not changing any of the angles, so the angles stay the same size. That's the important thing to understand about rigid transformations. To start the glossary terms, we have assertion. This is a statement that you think is true, but have not yet proven. So this is kind of like you making a claim that something is true, but you have not proven that it's true yet. It may seem true, it may seem like a common sense thing or something that you can just observe, but you haven't gone that extra step of proving it yet. Next, we have congruent. When we say that something is congruent, such as the triangles we have in the bottom right here, what we're saying is, even though they may have been translated to the right, even though they may have been rotated clockwise, even if they've been reflected, meaning flipped over, it's still considered congruent because the side lengths are the same and the angles are still the same. So that's the important part we want to pay attention to today. We're going to be sliding them around. We're going to be rotating them. We're going to be reflecting them. But we want to make sure that they're still congruent. So we don't want to make them any bigger or smaller. And we don't want to change the angles at all. Next glossary term is image. If a transformation takes A to A prime, when we see that one little tick mark to the upper right of a letter, we consider that to be prime. So we're saying we took A to A prime, then A is the original, and A prime is the image. So if you look to the right here, we have a triangle in the lower left, and then we have a triangle in the upper right. And you'll notice that the letters on the triangle in the lower left are A, B, and C. The letters in the upper right triangle are A prime, B prime, and C prime. So what this is telling you, if you follow that blue arrow, it's saying we simply translated that lower left triangle up and to the right, and it's now located where that triangle is in the upper right, but we didn't change anything as far as size-wise goes. So they're still congruent. So that means A becomes A prime, B becomes B prime, and C becomes C prime. The one that just has the letters is what we consider the original shape. That's where we started. The shape that has the prime letters is now considered to be the image because it's the new placement of the triangle that we created. Next, we have rigid transformation. This is what this lesson especially, but also the next several lessons are going to be concentrating on. And a rigid transformation is a translation, which means you're simply moving it up, down, left, right. It can be a rotation, which means you're turning it clockwise or you're turning it counterclockwise. Or it can be a reflection, meaning you flipped it over. So if I'm looking at the example in the lower right there, to go from the blue triangle A to the yellow triangle B, we would consider that a translation. We moved it to the right and down a little bit. To go from the yellow triangle B to the red triangle C, we rotated it clockwise. And then to go from the red triangle C to the green triangle D, we reflected it. We flipped it over. So it also says here we sometimes also use the term to refer to a sequence of these. So we could look at the individual movements, or we could say to go from the blue triangle A to the green triangle D, we need to translate right and down. Then we need to rotate clockwise. Then we need to reflect. So we could be talking about individual movements, or we could be talking about the whole series of movements that had to happen. And then the last glossary term we have for this lesson is theorem. This is a statement that has been proven mathematically. So we had the assertion, which was our statement that something was true. Then we have gone through the process of actually proving it mathematically. And now that we have proven it, it is now considered a theorem. Now let's go ahead and get started on the practice problems. Now we can start on the practice problems. Number 1, here are 4 triangles, that have each been transformed by a different transformation. Which transformation is not a rigid transformation? So what this means is we have A, B, C, and D. The blue triangles are the original, and the green triangles are the images. So we're trying to figure out which one of them is not a rigid transformation. Well, if you look at A, the blue triangle to the green triangle, what we did here was we simply translated it. We just shifted it down and to the right. So this is a translation. And a translation is a rigid transformation. So A is not the answer. If we look at B, notice that what we did to go from the blue triangle to the green is that we rotated it. We rotated this point C down, B is down, and A is kind of that axis point. So this would be a rotation. And a rotation is a rigid transformation. So B is not the answer we're looking for. Now if you look at C, notice that point C and C prime are right here by each other. What we did was we reflected it. If I just drew kind of this imaginary line right down the middle, I simply took B and I flipped it over. I took A and I flipped it over. So this is what we would call a reflection. And a reflection is a rigid transformation. So C is not the answer we're looking for. If you look at D, what happens is that triangle green, the image, is bigger than the blue triangle. So this actually got larger. And if it got bigger, then that is not congruent. And that means that they are not a rigid transformation because the side lengths are no longer the same size. So we have three rigid transformations. They are translation, rotation, and reflection. And in all three of those, the side lengths stay the same and the angles stay the same. That bottom right one, because it got bigger, the side lengths are no longer congruent. That is not a rigid transformation. I hope this helps clear the idea of a rigid transformation up for you. But if you still have any questions, as always, feel free to leave a comment below. Practice problem number 2. What is the definition of congruence? Remember that in order for two shapes to be congruent, they need to have the same side lengths and the same angles. So if we look at option A, it says if two figures have the same shape, then they are congruent. Well, I could have a small square and a big square. They're not congruent. I could have a right triangle and an isosceles triangle. They're not congruent. So just because they have the same shape does not mean they are congruent. So A would not be correct. Option B, if two figures have the same area, then they are congruent. Well, area you can think of as how much surface are they covering. And so I could actually have a square with an area of 2 square feet, but I could also have a triangle with an area of 2 square feet. So just because they cover the same area does not mean that they're going to be congruent. Choice C. If there is a sequence of transformations taking one figure to another, then they are congruent. Well, this is missing a part. It's not just a sequence of transformations. It would need to be a sequence of rigid transformations, because I could also make it bigger or smaller. I could also move one point and not the others. I would be transforming the shape, but I would not be making it congruent. So without this specific word of rigid transformations, then C would not be correct. Finally, we have D. If there is a sequence of rotations, that's a rigid transformation. Reflections, that's a rigid transformation. And translations, that's also a rigid transformation that take one figure to the other, then they are congruent. This is what it means to be congruent. These 3 movements are rigid transformations. And because they are rigid transformations, size stays the same, and the angles stay the same. And that is what is needed for congruence. I hope this helps, but if you do still have any questions, please feel free to leave a comment below. Practice problem number 3 will be the last practice problem in lesson 10. Once we're done with it, we'll go back and review the learning target. There is a sequence of rigid transformations that take A to A prime, B to B prime, and C to C prime. The same sequence takes D to D prime. Draw and label D prime. So remember, they're saying that we're doing rigid transformations. When we are doing rigid transformations, we can either do rotations, reflections, or translations. So if I was to look and go from the blue triangle, which is ABC, and I was to change it to the green triangle, which is A prime, B prime, C prime, it appears that we rotated clockwise and we translated right. So if D is halfway between B and C, then D prime should be halfway between B prime and C prime. So we can simply draw that point halfway between B prime and C prime and label it as D prime. So I hope that explanation makes sense in this practice problem and in all the practice problems we've done in this lesson. But if you do still have questions, please feel free to leave a comment below. Now let's go back, take a look at the learning target, and just make sure you've learned everything you need to and that you are prepared moving into the next lesson. Looking back at the learning targets for lesson 10, there were 3 of them. Learning target number 1 says that given a figure and the description of a transformation, you can draw the figure's image after the transformation. So this requires you to understand that there's 3 types of rigid transformations. An object can be rotated clockwise or counterclockwise. A figure can be reflected across an axis or just simply flipped over. Or it can be translated, which means move it up, down, left, right. So if they give you the beginning figure and they tell you what the steps are, you should be able to follow those steps and draw the new shape. Learning target number 2 says that you can describe the sequence of transformations necessary to take a figure onto another figure. So this time they're saying that if they were to give you the 2 shapes, the original and the prime, you would be able to say it was rotated clockwise or it was rotated counterclockwise. It was reflected across this axis, or it was flipped over this way, or it was translated up, down, left, right. How was it moved on the plane? So basically just they give you 2 shapes. They ask you, what did we have to do to go from shape 1 to shape 2? And you're able to describe the movements that would make it happen using just those 3 rigid transformations. And then learning target number 3 says that you know that rigid transformations result in congruent figures, meaning you understand that whether we rotate something, whether we reflect it, or whether we translate it, in the end, the new shape will still have the same size side lengths and will have the same size angles. It doesn't get bigger, it doesn't get smaller, it doesn't change shape. It's the exact same, or at least congruent shape. It's just now sitting differently. So as long as you understand these 3 learning targets, then you're exactly where you need to be moving forward into the next lesson. If you found this video helpful, in the bottom left of the screen, you'll see a video that YouTube is recommending for you. In the bottom right of the screen, you'll see a subscribe button for the channel. Please do me a favor and hit that subscribe button. Give this video a thumbs up. And as always, please engage with a comment below. And I look forward to seeing you in the next lesson.